our task is to reorder array by odd and even numbers, and we have the following description. Given an integer vector, reorder it so that all odd numbers precede all even numbers. And so we have a vector of integers or vector of numbers as our input, and then we have to reorder it such that all the odd numbers come first. And so we have to divide it in two subparts, but still within the same container. And the first part has all the odd numbers, and the second part has all the even numbers, and then we return it in such a way. And so the output array has to have a certain order, and the relative ordering within the odd or even groups doesn't need to be preserved. And so we only care that all the odd numbers are first and then all the even numbers, but they don't have to come in the same way they were in the original input array. And so we can change the order, just that they will be separated in those two groups. And we have some constraints. The input vector length is between 0 and 10 to the 6th. That's usually the case, so nothing fancy here. And elements in the vector are integers between int min and int max. And so, of course, we can use just normal int. We don't have to use longs or anything like that. Then we have an example where we have just positive numbers, and those are like consecutive integers 1, 2, 3, 4, 5, 6, and 7. And one of the possible output is 1, 7, 3, 5. Those are all odd numbers, and then the even numbers 4, 6, and 2. And that's one of the ways we can do it. We will implement two solutions. First, using some extra space and doing simple iteration using a loop, and simply adding to this extra space, like we will create two additional arrays or two additional vectors, one for all the odd numbers and all the even numbers, and we will put them in the appropriate array, like this additional array that we will create when we will iterate through the input array, and by the end we will merge them to a single array and return it. And so we can do it this way. It's still ON operation, and we just use some extra space. But we can also take advantage of more advanced C++ features like std partition. There is such a functionality, and we will try to use it, and then we will be able to solve this problem in place, but still the time complexity will be ON. Yeah, so just to show some of the more advanced C++ functionalities. And then we have test cases. All of that are just some additional helper functions for the tests. And finally, in the main, we have all the cases, like the example that we had, which has mixed odds and evens. Then odds are first, then all evens or odds, empty array, single element which is odd, single element which is even, alternating start, and so on. And then we'll test both of our solutions and see if they pass all the tests or not. So let's start implementing. But first we will use a helper function, which we'll use in both. So let's implement it for checking if the number is even or odd, or just checking if it's even. So if it's not even, that means it's odd. And we can do it, for example, using bitwise operations, bitwise AND, like this. Check AND with 1, and then we will check if the last bit and the last digit in the binary representation is 1. If it's 1, that means that the number is odd. And so we have to check if it's not 1, meaning if it's 0 for the even number. Yeah, and we could also do like an opposite check, make a function which is odd, but I think that is even is like not more general, but at least in my head, I like to think about numbers like I prefer the even numbers and not odd numbers. That's why it's there. And that's the only reason for that. And of course, there's also a way to check using the remainder from division. And so if we divide a number by 2 and the remainder is 1, then that means that it's an odd number, which is like the same thing we are doing here, by the way. And just we could use the percent operator and so But we will not do it. We will keep the bitwise end here. So that's about the helper function. And now let's implement a simple solution. We create two additional containers, one for odd numbers and one for all the even numbers. And then we can iterate through each number in our input array. And if is even, if the number is even, then we add it where? We add it to the even array with bracket. Otherwise, we add it to odd array with bracket number. Now we have two separate vectors, but we want to have them merged together, and we can use simply insert functionality which already exists for the vector. And at the end of the odd vector, we'll insert the even vector from the start till the end. Then we'll return odd vector, and that's it. Now let's try to compile it. And there's I forgot. Close parentheses. And start, not begin. For some reason in my head, the opposite of end is start, not begin. But the iterator is called begin. That's it. So now we can compile, and all the tests for the simple solution pass. Now let's try more advanced solution using std partition. And starting from in, then end. And here we can create a lambda function that will be used for the partitioning, and inside it we'll call our isEven helper function. And that's it. Oh, this back. Let's go. Take a look again. Ah, yes. Turn. And one more semicolon. Now let's compile again, and all the tests pass successfully.